Once again, welcome back to my dear friends to the Tech Civil Learning. As you know, the main motto of our channel is to provide the practical educations or to connect the students to the practicals level so that they can understand the concept very clearly. So my dear friends, just give me your 20 to 30 minutes time. You will surely going to understand the concept which is mentioned in the thumbnails, and this concept is very essential for the university type of exam or the means any competitive types of exam. So let's understand the concept very clearly. So let's start. So today we'll deal about means rain gauge means network, right? Means as you know, we have already discussed about the rain gauge, right? Means what means measurements of the rainfalls, means what are the different types of rain gauge used for the means measurement of the precipitations and the rainfalls. So in the same way, similarly, we'll discuss about the rain gauge networks, right? First of all, so why rain gauge networks is essentials to study for the civil engineers. Well, my dear friends, we have to aware about all these things. So as you know, rain gauge, yes, you have a well concept about the rain gauge. It is an instrument used to measure the intensity of precipitations or the rainfall. Similarly, rain gauge networks, right, means there is a provisions of the different types of rain gauge, right, means or the different means numbers of rain gauge, right, means in this in a imagines in a catchment area, means there are there is a networks of provisions of the rain gauge, and we need to provide means rain gauge, or we need to design the rain gauge networks. So because as you know, my dear friends, rainfall data is very important and the fundamentals data required for the any or the all hydrological means what you call investigations. So rainfall data, as it is very important in means what you call in such a manner like the analysis of storms, right, fixing design floods. Similarly, if you talk about the reservoir means regulations, so that's why means rainfall data is very essential. So we have to means study about the rain gauge network so that we can collect the rainfalls or the means what you call amount of precipitations. So here, as you can see, it is very absolute essentials to design the proper network of rain gauge in the given catchment area, or catchment area is also known as watershed, to collect the necessary precipitation data. Means to collect the precipitation data, we need to means design a proper rain gauge networks. And why precipitation data is required? Because to analyze the storms, to fixing the design flood, right, means reservoir regulations. So it is very essential in that manner. The one technical term, that is catchment, right, means catchment area is also known as watershed. Here, my dear friends, catchment area is nothing but it is a natural area, right, means it is a natural area means of the waters, right, it is the natural area of the water following in the direction of certain location, right, which usually is situated at the rivers or the similar flow of waters. Or we can also say that it is the area of land means where the water is used to follow to the means a certain area means and which is situated near the river or water flow. So this is nothing but the catchment area. So here means rain gauge networks is essentials to estimate the what you call average rainfalls, right, means how much means rainfall takes place, how much amount of precipitation takes place in the per day, per hour, or either it may be the annual, right. So we need to means we need to get all these informations from the rain gauge networks. So what happens, the rain gauge networks means accuracy totally depend upon the total numbers of rain gauge means used in the means what you call in the catchment, in the particular catchment area. Imagine this is a catchment area, right. So how many numbers of rain gauge we have used in that area, means its accuracy is totally depend on that ones and the location of rain gauge, right, means what does it means, the distance between two rain gauge is sufficient or what you call efficiency or not, right, means the distance between the two rain gauge is efficient to give the accuracy or not. So the accuracy of the means what you call network, the accuracy of the rain gauge networks is totally depend upon the what you call the total number of rain gauge used in that catchment area and what you call the locations of the means what you call gauge in the catchment area. So we know all about the means rain gauge networks, right, means the provisions of rain gauge in the catchment area, right, which means from which we can estimate the average rainfalls or the precipitations. So similarly means rain gauge density, from that ones we need to study about the rain gauge density or the network density. So it is nothing but the total catchment area, right? Means what is the area of that catchment, right? Means these ones total catchment area and the number of rain gauge means used in that ones, right? If it is the catchment area, right? So the total area of this catchment by the number of rain gauge used in that one. So this is nothing but the rain gauge density or the means network density, and it is very essential for the competitive exams. So we have to analyze all these things very clearly. So hope you understood till here. So now my dear friends, some of the standards means data which is given by the meteorological organization, right? The old meteorological organizations have given certain standards data about the means what you call means different means provisions of the means what you call rain gauge networks, right? Means where means how many numbers of rain gauge we have to use in the flat area, at mountain area. So there is a standards. After all the investigations we got this data. So once have a look. So for the flat regions of temperature, right, in the if you talk about for the flat or the plain regions, in the plain regions we have to means one rain gauge for 600 to 900 square kilometer, right? Means one the distance between means one, I mean to say that the one rain gauge, right, one rain gauge should cover the area of 600 to 900, that is the minimum. And if you talk about the maximum or the tolerables is one rain gauge for 900 to 3000 kilometers. Beyond that means it means if you use one rain gauge beyond that area, then of course it may give means what you call error. And here Mediterranean regions means nothing but the regions which is means what you call which includes summer as well as winter. So in this types of means one rain gauge is sufficient, means one rain gauge is sufficient for the 600 to 900 square kilometers. Similarly for the mountain area, right, for the mountain area, as the rainfalls in the mountain area is high, as you know, so one rain gauge can cover 100 to 250 square kilometers only, right? This is the minimum what you call minimum network means density, or the minimum network means what you call rain gauge density. And if you talk about the means what is called tolerables, then it is 250 to means 1000 square kilometers. Similarly for the arid and the polar zones, right? Arid zones is nothing but means it is a zone of having means we can say that a severe lack of available of waters, means there is a lack of available of waters. It is like a means what you call desert type means regions. And polar, we know the polar means having the means freezing area, right? So in that ones one rain gauge is sufficient for means 1500 to 10,000 square kilometers, right? And its tolerables is not means what you call substituted. So this is all about the standard data to be understand. And in India some of the means IS code recommendations is that for the plain ones, that is for means for the flat area means for the flat area one stations for every 520 square kilometers, right? Means 520 for the every means what you call for the one rain gauge we have to provide 520 square kilometers. Similarly in the regions with the average elevations of 1000 meters, one stations per means gives 260 to 390 square kilometers. Similarly in the hilly with the high rainfalls, one stations for every means 130 square kilometers. So this is the means IS code recommendations which is given by the IS 4987 1961, and in that ones it is also given that means 10% of the means rain gauge are recording type rain gauge. So this is all about the rain gauge means what equals network. Hope you understand the rain gauge network. So let's have talk about the means optimum number of rain gauge. Optimum number of rain gauge you can understand in simple or in general way that the additional number of rain gauge required in the catchment area, right? If the numbers of rain gauge means seems to be shortage in that one's catchment area, right? If this is catchment area, and in that ones if the numbers of rain gauge seems to be shortage, then of course it means what you call we will get some errors means in estimating the average means rainfall, right? So what we do means for the eliminating of these errors we need to calculate the optimum number of rain gauge or additional number of rain gauge required in that one's catchment area. So here it given if there are already some rain gauge, yes, already there is some rain gauge in the catchment area, so optimum number of station that should be exist to have assigned the percentage of errors in the estimations of the mean average rainfall, right? What I have told you is the givens. So that can be given by n is equal to CV by P whole square, right? Its total square, where n is what you call optimum numbers or the additional number of stations, right? Similarly, CV is nothing but the coefficient of variations of rainfalls, and P is the desired degree of errors in the estimations of the mean rainfalls. It is already given in the question. So based on this there are lots of numericals and frequently asked numericals are coming out in the university type of exam, so we need to understand very careful. So let's how to calculate this one, let's see. So here's, as you can see, the n is equal to CV by P. So what is the formula of CV? So let's understand the formula of CV. As you can see, CV is nothing but what you call here sigma represent nothing but the standard deviations, and in some of the textbook it is also represented as Sx. So there is it's totally depend upon your own thought, right? Your own representations, your own notations. So that is sigma by x bar into 1000. So CV is represented in percentage. So here now what is this one? So how to calculate sigma, right? How to calculate a standard deviations. So standard deviations can be calculated root unders summation of x minus x bar divided by n minus 1s and x minus x bar whole squares. Here x, what is x bar? X bar is the mean what you call rainfall value, right? In that ones, in the questions you have given some mean rainfall value like 90 centimeters, 80 centimeters, right? It's totally depend upon the times. So we need to calculate all these things. X bar, we have to take the mean of all that rainfalls. Similarly, where n is the number of existing stations, it's already given in the questions. So what equals x bar, the summation of x by n, as you know, we can calculate easily. So here, so hope you understand this formula. So let's see one numerical so that it clears all your doubt. So my dear friends, as you can see here, a catchment has 5 rain gauge, right? If there is a if this is a catchment area, right? So it has 5 rain gauge, 1 2 3 4 and 5, right? So each rain gauge records its own intensity of rainfall, right? It's like 78.8 centimeters, right? 90.2 centimeter, 98.6 centimeters, 102.4, similarly 70.4. These are the 5 what you call intensity of rainfalls which is recorded by the rain gauge, and 6% errors in the estimation of the mean rainfall is given. So everything is given in the question, just you need to calculate the additional number of rain gauge required, right? So it's very easy and simple. My dear friends, we have already known this formula that n is equal to Cb by P whole square, where Cb can be calculated by Cb can be calculated, that is sigma by x bar into what equals 100. So here the x bar can be calculated the mean annual rainfalls. Already we have given 5 rainfall 78.8. So we divide by 5, it gives your mean rainfall. So mean rainfall comes 88.08 centimeters. Here the rainfalls always represent either in centimeters or in mm's. So I have already discussed about what does it means in the previous video. So if you have not gone through that one, please go. It really built up your knowledge. So we have already calculated x bar. Now we need to calculate, that is how to calculate, that is sigma, right? So sigma can be, we know the formula, that is summation of x minus x bar by n minus 1, right? And sorry, here it will be a square, right? Here it will be a squares. So if you substitute the square here, then the root will be cancels. So 70, here the x value is 78.8 and the x bar value is 88.08. Similarly, the second rainfall value is 90.2. So we will do all these things and divide by n minus 1. That the number of rainfall what equals number of rain gauge is 5. So 5 minus 1. So ultimately sigma value comes 13.41. So what we will do, we will substitute all this value in this one. So sigma by x into 100. So it comes 15.22. So we will substitute Cv, that is 15.22, and here P is nothing but the error, right? So error is given 6%. So 15.22 by 6 into means whole square, so it gives 6.43. so ultimately in round up the 7 value. So the previously means here the 7 comes, and the previously we have means already used 5. So here the 2 additionals, means the additional number of stations required is 2. So means we have to means add 2 additional stations. So similarly you can solve any types of numericals based on that one. So once you can see these questions, here also 6 stations is given, right, and the 10% error is given. So here we need to calculate the additionals or the optimum number of stations, where the answer is 9. So hope you can calculate these ones. If you have any doubt, then please put your comment in the comment sections so that I can clear all your doubt. So let's talk about the another topic. Hope you means till here. उम्मीद करता हूँ कि आपको समझ में आया हो, right? I hope you have understood till now. So let's start another topic. Here we will discuss about the means what you call representations of the rainfall data, means presentations of the rainfall data, means how the rainfall data can be representations, right? So once we collect the rainfalls in the rain gauge, then we have to means what you call say represent it through the various methods. So we will discuss about all these methods, which is very essential. My dear friends, all these topics are very essential. So please means concentrate yourselves to have means evident knowledge or to have a comprehensive knowledge, technical knowledge in these fields. So there are the 3 methods which can use to represent the rainfall data, that is means a hyetograph method, similarly mass curve of rainfall methods, and the point rainfall methods. Or lots of multiple choice questions are coming out from these types of means what you call concepts. So understand this concept very clearly. Here means what you call hyetograph means nothing but the representations of means what you call intensity of rainfalls vs time. So intensity of rainfalls should be represented in the y-axis, at the same time time in what you call x-axis. So as you know, the time is means independent of the means intensity. So we have to represent the independent quantity in x-axis and the dependent on y-axis. So as you can see, the 2 4, that is 2 hours, 4 hours, 6 hours, and here the means rainfall intensity. So here 0.4 centimeters. Similarly here at the 2 hours is 0.8. Again it is same, means it means the rainfalls means continuously varying, right? Means it is not constant throughout the all the day or all the time. So it is continuously means what you call varying. So as you can see, the means it is a graph showing the intensity of rainfalls with the times. And the hyetograph can be prepared either means it can be represented either the mass curve we will discuss about in the next topics, and that is and it can be directly taken from the automatic rain gauge. So it can be directly taken from the automatic rain gauge, because in the automatic rain gauge all the details are available. So here my dear friends, we will talk about the mass curve of rainfall. Similarly it is also representations, right? It represents the what you call cumulative depth of rainfall against the times. Here means there are the numbers of means what you call in the catchment area, there are the numbers of rain gauge are used. So the average of this what you call depth of the rainfalls vs the time. So we will means represent in this one. So a stiffness of the curves indicate the intensity of rainfalls, right? Means in this ones, as let me show you figures. As you can see, the means there is a means slope of having the curve. So the stiffness of curves indicates the means what you call intensity of rainfalls. Here in the some of the curves, if the line is totally horizontal, then it indicates there is no rainfalls during that period. So we have to consider all these things. Similarly mass curves, rainfall is a rising type of curves, right? It means it is a rising type of curve. So the intensity of this one can we calculate del p by del t. So let's see the figure so that you can understand. My dear friends, this is time as usual, and this is cumulative intensity of rainfall. So as you can see, this one is A point. So from A to B, this one is the intensity of rainfall. Similarly from B to C, it is horizontal, right? It is horizontal means no rainfall, no rainfall. Similarly from B to C, there is a rainfall, right? So B to C of having the intensity of rainfall. Similarly D to E is no rainfalls. Similarly up to here there is a rainfall. So this is the means intensity of rainfalls, which is means represented by the mass curve of rainfall. Similarly it can be also represented as a point rainfall methods. Point rainfall method is a very simplest type of rainfall methods. That means in this one what happens means rainfall data of the stations is known as the point or the station's rainfall. Means point rainfall method is also known as station rainfall methods. So in this one what happens, rainfall data of the stations is collected and directly it can be measured. So what happens, this data can be means represented as in the daily, weekly, monthly, and the seasonal or annuals. It's depend upon the requirement, right? So if it is very required, then we can means what we call represent it as a daily, weekly. It's depend upon the means what we call requirement. So the point data are usually collective, means to estimate the means what we call aerial variations of the rainfalls. It is also means used to means driving the intensity of durations and the frequency curve. Later we will discuss about the intensity, duration, and the frequency curves. So at that point you are going to understand the concept very clearly. So thank you my dear friends for watching video, so that hope you have means knowledge on this content. Hope you have knowledge on this concept. If you have any doubt, please means put your comment in the comment sections. If you need any help related to the civil engineering, so please put the comment in the comment section, so that you will connect with us. And thank you for watching the video. Thank you. Take care of yourself. Bye bye.